I'm Jacob Kaplan-Moss. I'm one of the lead developers of Django. And I'm going to be sort of rehashing a talk that the other lead developer, Adrian, and I gave at DjangoCon, which was held here at Google in September. We showed off, kind of for the first time publicly, what Django looked like in the couple of years before it was released as open source. It's a pretty funny. It's some pretty funny stuff. I think you'll see some really interesting things here. So for me, this is where I start thinking about where Django is and where it's come. I think this is one of the most apt observations about software that I have read anywhere, which is that good software takes a really ridiculously long time. Am I right in remembering that Google is about 10, it's just turned 10, right? I think that there's a pretty magic number there and around that 10-year period. So, you know, we are halfway there. And looking back at where we've been, I think hopefully will be a continuing trend forward as we move on from there. So, excuse me a bit. So Django was born in Kansas, which comes as a pretty big surprise to anybody who is involved in tech. Most people think that the Bay Area, or maybe New York, maybe Chicago, maybe Boston gets to live up there with places that invent cool stuff. But I'm here to tell you that Kansas, despite some of the stuff you may have read in the news, it's actually a neat place, and there are smart people there too. Specifically, Django was invented at the Lawrence Journal World, which is a small, family-owned, since the 1850s newspaper in Lawrence. It's a town of about 80,000. The paper has a circulation on the order of 20,000. I don't know the exact numbers. Not exactly the place you would expect to find these guys working. That's Adrian Halavati on the left and Simon Willison on the right. You might recognize Adrian's name as the creator of Chicago Crime, which was the first Google Maps mashup. And if you look on the very early Google Maps discussion list, you can see a post by Adrian encouraging them to release an official API. He actually reverse engineered the Google Maps JavaScript stuff to embed it on his own site. Adrian is also extremely well known within the field of journalism. He's coined the term database journalism to describe what he does on Chicago Crime and on his new startup, Every Block. Simon on the right there, he's not always blue, is you probably know him sort of as a JavaScript luminary. Some of the stuff that he worked on early on is now part of the current crop of JavaScript frameworks. He's also one of the bigger OpenID evangelists out there. But he's sort of a general all-around tech maven. I had been following these two guys for a while, really impressed with what they did. And so when a job opened to go work with both of them, the fact that it involved moving to Kansas didn't seem like that big a deal. So back in 2002, 2003, when Adrian started working there, the project that they were working on was this, Lawrence.com. This is now maybe the 6th incarnation, maybe 7th of the site. Lawrence.com is the site that you wish your town has, but doesn't. It's a local entertainment site that tells you what's happening, what the local bands that are playing, what the drink specials are at your favorite bar. It's sort of the one-stop shop for nightlife in Lawrence. And it just beats the pants off of any other similar site anywhere. If you've seen Metro Mix in Chicago, they wish they had this. City Search, Google Local, got nothing on us. The thing about it, though, is you've got to remember, this is a tiny little company trying to develop this thing. This was originally developed by Adrian, a designer, Dan Cox, and an editor, Phil Cawthon. 3 guys. And this site has absolutely everything. It is the comprehensive place to go for information about Lawrence. So small team, big ambitions. Originally, they started writing this in PHP. I'm not going to go over the reasons why that didn't work out. Those are well documented. What I'll say, though, is that Adrian and Simon knew pretty early on that they wanted to switch to Python. But circa 2003, the state of the web in Python was a disaster. This is from Mike Orr's roundup of a talk given at PyCon in 2005 about the current state of web development in Python. This quote refers to circa 2004. By 2005, the situation was even worse. At the talk given at PyCon, there was a slide with over 40 Python web toolkits of some sort or another. Template languages, dispatch mechanisms, ORMs, all sorts of pieces. And it was nearly impossible to know which were robust enough to use, which were going to work for your site. And you're just not feasibly going to evaluate 15 or 30 or 40 different technologies. There was no WSGI at the time, WSGI, which is the glue that today binds together the Python web world into sort of a more unified whole. There was no real serious discussion of the web as an important place for Python to be at that time. So Adrian and Simon did what most engineers do when they're confronted with a very confusing technology landscape. They started from scratch. This is change set 15 of the internal repository from which Django eventually came. This is originally a CVS repository converted to Subversion. And what's kind of cool is this was the very first code that was checked in to the repository that Django came out of. All the previous commits were setting things up and various cruft that CVS to SVN threw in there. And if you look at this template library that Adrian checked in 2003, this is the example template in that template library. It's nearly identical to this template would almost perfectly work right now. There's a couple of things. There's no by line list tag that Adrian kind of made up there. And we don't allow hyphens in variables anymore. But other than that, this is an exact replica of what the template language in Django is today, over 5 years later. This is what the context class looked like back then. The context is what a template is rendered against. It's essentially, it was conceived as a stack of dictionaries, the idea being that when you enter a block tag like a for loop or an if statement, you don't want variables from inside that loop to leak out to containing contexts. That's what this simple data structure was. Here it is in 2003. Here it is today. It's almost identical. There's actually, you could do a really good sort of programming quiz problem on why the slight change in semantics between the 2003 version and the 2008 version was done. There's some very small differences that actually have important ramifications. And that theme kind of persisted as I looked through the early days of Django. Most of the stuff that we now see in Django, or much of the stuff we now see in Django, existed in a very rudimentary form all the way back then. Revision 36 introduced the poll app. If you go through Django's official tutorial, you'll be building up this app that was introduced in 2003 at revision 36. I should mention, by the way, that at the time, there was no Django, there was no framework. It was just the CMS. We're pretty bad at coming up with code names, as you'll see in a minute. Revision 84 introduced the validators framework, which is now part of the form framework in Django 1.0. Revision 159 introduced the paginator. The paginator is a really neat abstraction for dealing with large data sets and paginating through them, a common thing to do in a web application. The current paginator in Django is somewhat different, but the core concept has been there since 2003. The auth app was introduced very early on, and it's nearly identical in terms of the data structure to the way it is now. Now, there are some people who say that that's not necessarily a good thing, and we can debate that. But the fact is that it was developed there very early on. The URL resolving mechanism. So we had these apps, but there was no, or I should say they had these apps. I wasn't there yet. There was no way to actually hook them up to a website until this came along. And I'll look at this in a minute. The sites subframework, now Django contrib sites, was introduced also incredibly early as a way of differentiating between requests to different URLs. Also introduced extremely early on was the admin interface. And this is what it looked like in 2003. It was just a very basic, really ugly HTML form. There was no designer working with them yet. But by February 2004, circa revision 1000, if I gave you this code right now and gave you a couple of bits of information about how to mentally convert from what's in Django now to what was in the CMS then, you'd be able to start writing applications and things would feel very, very familiar to you. This completely blew me away when I went back and started looking at when these things were introduced. I'm completely amazed at the vision that Adrian and Simon had sort of from the very beginning. To give you an idea, by the way, of how this was being built, around revision 1000 is when the not clause for the if tag was introduced. So this was being built very piecemeal. There was sort of a rough outline of what things were, but large pieces of functionality were completely missing. So this is what a model, such as it was, looked like back then. You can see it doesn't inherit from anything. There's no meta-classing going on. This is just a plain old Python class. And in fact, if you look at the save method, you see that there's just a bunch of hard-coded SQL embedded directly in there. There was no subclassing. There was no dynamic generation of SQL. There was really nothing. You wrote a model, such as it was, by hand. And it was just a plain old Python object that happened to have the save method that ran a bunch of really ugly SQL. And every time you wanted to write a new object, you would write another one of these by hand. But using it looked reasonably similar to the way using a model looks like right now. You would import the model, you would instantiate it, and you would save it. This almost works today. You'll notice, though, one of the really ugly things early on, models didn't accept keyword syntax, so you had to remember, okay, the 7th argument is the number of days to keep it open, and the 9th argument is the URL piece. It was tough. It was tough. So you had a way of saving models into the database, but you needed a way of getting data back out of the database. So to do that, you would write some functions by hand, get poll by ID. And you can see there's just some SQL code written right in there to look up a poll by ID. And if you wanted to look up a poll by its label, you would write get poll by label. And if you wanted to look up a poll by its date, you would write get poll by date. Again, no magic, all by hand, totally plain and simple and easy. Well, sort of. Whoa, what is going on there? Yeah. Well, hope that's good enough. So, yeah, that's a good one.
To keep us on our toes as the audience.
Well, the colors you're seeing are completely different from the colors I'm seeing, but I think that that's readable. Isn't technology awesome? I love this. Where was I? Right, so that was how you looked up a single object. If you knew you wanted to look up a list of objects, you would write a get poll list function. That name will look familiar to anyone who started using Django very, very early on. And I'll explain why that is a bit later. Sort of make a mental note of it. There was also no generation of SQL. You would open a file by convention called dblayout.sql and write your SQL and then stick it in the database by hand. There was also no concept of a sort of root dispatcher or a root URL conf. You would have to have a separate location block in your HTTP conf for each app that you wanted to have. You can see there was this Python option app thing, which would point at the app you wanted to use, which meant, of course, if you introduced a new feature to your site, you'd have to reload Apache and edit your HTTP conf, and that was super fun. But this is interesting. This is an early URL conf, again, circa February 2004. And the basic idea was there from the very beginning. You have a pattern, which is a regular expression, and you have a view, which is a callback that gets called when the URL matches that pattern. I tried to figure out what these other things are in here. There's 4 items in this tuple. There's a pattern, something that's always none, and something else, I think, which the last one's the view. I don't know what those middle 2 pieces are. But you can see the name, URL patterns, that was there in the beginning, and this concept of having 404 and 500 handlers as a fallback, still there in Django today. And finally, you'd write a view. Now, the views are kind of cool because this view would basically work right now. If you changed get poll list to poll.objects.all, everything else would essentially work. The basic workflow of look up some data, load a template, render the template given the context, return an HTTP response, that was all there from the very beginning. As I understand it, the idea always was that views were supposed to be really wide open. The only rule for a view then was it takes a request and returns a response. And the only rule for views now is they take a request and return a response. So you put this all together. This is what writing an app in Django in the CMS looked like circa 2004. You would write your data class. You would write an admin view by hand, I should mention. You would write the data access functions. You would write the admin template by hand. You'd write the admin URLs. And I'm missing here the views you would write, and et cetera, et cetera. This obviously is not a great way for a small team to develop things rapidly. So around, what is this? March 2004, Adrian checked in this code. Data descriptions and the code generation library, which should be giving you willies just thinking about it, but just wait. So the idea was you were doing these same things over and over again. You're writing a data class, you're writing an admin view, you're writing data access functions, you're writing an admin template, you're writing these URLs. You were kind of writing the same things over and over again with very small changes. And so why can't we sort of dynamically generate that boilerplate from some sort of a description of the data that you want to be able to store? And that's what these data descriptions were. So here's the poll data description. And it's really verbose, but you can see that it's already starting to resemble roughly what a current Django model now looks like. There was all of this boilerplate you had to do. You had to provide a doc string and the database table, and all of these things were required. The fields were very verbose. I really don't know. I don't know why there's so much verbosity here. Auto increment field was required. That same line is the primary key ID that Django adds in most cases automatically now. You had to spell it out in full. You also have stuff like create list lookup function. Now, if you remember back, I was showing the slide where you would write the list lookup stuff by hand. This would automatically generate those types of get poll list functions. But you had to specifically say which were the fields you wanted to be able to use when you were looking up a list. So notice that the slug there has that lookup equals gen.exact. You had to actually, at model definition time, tell the CMS what fields you were going to want to look up by later on. And that was because there was nothing actually dynamic going on here. You would write this file, and then you'd run this, generate code.py. And that would do what the name implies and generate a whole slew of code. You would get a polls.py module. This is just a plain Python file written out by reading this data description. You would get polls.sql, you'd get the admin view, you'd get a bunch of templates generated and a few other files that I couldn't quite remember. I managed to roughly get this code working the other night, but it was hard to get set up. So, so this is the awesomeness that is the code generation library. This is a 2,000-line file, all that looks like this. It's the most mind-searing code you can possibly imagine. The problem with generating Python is that indentation is what controls structure, right? So you have to be able to keep track of indentation in your Python code. You can't just throw a brace and an end brace and not really worry about the white space there. So there was this library, this code generator library, where you would give it the number of indents to use. And in a way of trying to appease the masses, I suppose, that library actually can use spaces or tabs, depending on how you want your code generated. But you can see just some amazing stuff in here where you have to keep track of, notice at the bottom here, you have to keep track of whether you have a primary key or not so that you know what level to indent the next code. You're saving level equals 3 or level equals 2 so that you keep track of where that code ought to live. And if you get one of those numbers wrong, I mean, you know, if you have a 4 instead of a 5 somewhere, now your file doesn't work. And it's all like this, 2,000 lines, all like this. And anytime you wanted to make a change, you would have to go in and modify it. But it's even awesomer than this. It's even better because remember that data description isn't actually used by the running code in any way. It's purely, it could have been a text file. It's purely a bit of configuration to be used by the code generator. So if you wanted to modify model behavior, add extra stuff to your model, you'd actually do it by putting Python code inside a string. Extra model code, extra model class code, extra model code top, extra model code bottom, extra module code. You would put these things in here and notice the rather interesting indentation in extra model class code. Remember, you have to get the indentation right in that string so that your code will properly show up in the right place in your file. And of course, you don't get syntax highlighting. You can't check the syntax of that. You can't analyze that code in any way. All of the outputted files had this up at the top of it. I just love it. It was generated by a program. The dubiously clever aspect of the code generator was that it would check for this comment at the top of a file when it got ready to overwrite it with the new version. And if the comment had been deleted, it wouldn't generate the new code, right? The idea being that if you wanted to make a change to the generated code, you could delete the comment and then just make the change. So you'd sit there and you'd make a change to your data description, rerun the code generator, restart your web server, and your change wouldn't appear. And you'd go back to the data description, scratch your head, make the change again, rerun the code generator, restart your web server, and the change wouldn't be there. And after 4 or 5 iterations, you'd be sitting going, why isn't this working? And it wasn't working because you would modify that code a while back. So obviously, completely untenable. The germ of a good idea, but not a good idea in its own right. We were kind of proud of it at the time. I remember pretty clearly, Adrian and I were up in Chicago, and we showed this off to Ian Bicking, who's another big name in the Python community. He helped write the WSGI spec. And Ian kind of got one of those horrified looks on his face and said, have you guys heard of meta classes? Well, so 7 months later, Adrian checked this in. And this was code, model/meta.py. The first release of Django, the first open source release of Django contained this code. This was conceived as a backwards compatible, we had a whole bunch of code already written, replacement for the code generator that would do the generation dynamically in memory instead of writing stuff out to disk. It's not quite as bad at that. It didn't actually generate code and eval it, but it basically had a whole bunch of really gross meta-classing hacks to emulate the behavior of generating all these modules all over your disk. So here's what the code looked like. Here's what a model looked like under this system. And another sort of increment step closer to what Django looks like now. The big difference between this and a data description was the introduction of the meta class, which you notice is still a meta.data description. The idea of calling this thing a model hadn't really occurred to us. We still had a sort of mental separation between the data description, the description of your database layout and what the fields are on your model and those sorts of things, and the actual models itself. When this meta class loaded, it would actually create you can see that there's a module name option there, module name equals polls. It would insert an entry into Python's module table so that you could import that module as if it were a file on disk. Again, it was trying to copy this previous code generation behavior. Around that, this is a screenshot taken around that time of the administration page, maybe just a little bit later, because by this point, obviously, we had the name. But we had the styles, and we had the look and feel of the admin done circa 2005. But at that point, Django was still, it was still the CMS. It was still this tool that we use to produce our websites. We had no real thoughts of this being any sort of general purpose tool. We hadn't really identified the difference between the sort of frameworky parts of it and the CMS-y parts of it. And we hadn't really thought about open source. I mean, it didn't seem like we had anything that would be useful outside of a journalism newspaper context. And a couple of things happened that sort of changed that view. The first was PyCon 2005. When one of the big topics was, why is web development in Python so hard? And by this point, for us, it kind of wasn't. And so hearing a bunch of people tearing their hair out about how hard web development in Python was had us going, well, I mean, maybe we should show off what we have. So Adrian gave a 5-minute lightning talk. He did the classic build a weblog app in 5 minutes thing that everyone does with everything. But it was kind of a runaway success. And we had people coming up after saying, man, you really have to open source this. This would be the best thing ever. You know, I need this. The other thing that was going on around that time was Ruby on Rails was reframing the debate around web development. I can't stress enough how much credit I give to Rails for redefining the terms that we talk about web development. Rails came along and said, why is web development boring? It shouldn't be. Why is it a drag? Why is it repetitive? Why is it a lot of work? Why can't it be fun? Why can't it be interesting? Why can't we think about our websites as applications, as large units of code, rather than a bunch of collections of pages glued together? And we looked at Rails with a certain amount of envy. We said, well, they're getting all this great press, deservedly, but we think what we have is better. So we started jumping through the legal hoops of releasing Django as open source. And we also started thinking about what to name our web framework. These are some of the names we came up with around that time. I'm personally partial to Brazos. I just think that's got a great ring to it. There's also some really amazingly bad ones in there. Private Dancer, that's just embarrassing to me. Garbanzo, I kind of like Garbanzo. That's got a good name to it. We wanted to name it after Simon, but he didn't think that was a good idea. We were very, very close to calling it the Tornado Publishing System and releasing it with a reports module, tps.reports. Office Space. Thank you. But it turns out that that name is taken. We actually instituted a trademark search on that name, and it turns out that it's actually taken. There's a company that sells a product called the Tornado Publishing System, so we were out of luck. I can pinpoint the exact moment at which Adrian came up with the name Django. Actually, this page is still there on the Journal World's internal track install. And at that point, it was decided. So we spent the next 4 months, splitting up the sort of frameworky stuff from the CMS-y stuff. The parts that were of general purpose, of general interest, became Django and was released as open source. And the sort of newsy CMS stuff was kept internal. It's now a commercial product called Ellington. And actually, if you look at early versions of Django, you can see that this split wasn't completely easy. There were still certain hooks deep in the bowels of Django that would look for pieces of Ellington still there. We first started that. We started doing the big split in early June. This is when I added the Django directory. And we knew that we needed to do a few things before we could release it as open source. At that point, Django was very, very tightly tied to Postgres. And although we love Postgres and think everyone ought to use it, the reality is that MySQL is sort of the dominant web database. So in early July, we refactored the database parts to make it possible to have multiple database backends. This turned out to be a pretty big deal. These days, we support the big 3 open source databases, MySQL, Postgres, SQLite, as well as Oracle. And there are third-party modules that add SQL Server support, as well as some more esoteric stuff like Firebird and what have you. And we're continuing to sort of expand that capability of Django to talk to other database engines. The reason I mention this is this was the first time, this was the big corner turn we had to make as developers from scratching our own itch to trying to anticipate and scratch other people's itches. This was the first thing that we checked into Django that we were never going to use, that spoke to other developers. And that was and continues to be a really hard thing to do in that transition from closed source to open source, is realize that it's not necessarily anymore about what you want. It's about sort of anticipating the needs of a community and responding to them. So switching now to a different track install, this is Django's track install, code.djangoproject.com. As you can see, changeset 3 was the initial import of Django from our private repository, created from revision about 88,000. Keep that number in mind. I'm going to come back to it a bit later. Adrian gave a sneak peek of Django. The site was barely up at that point. We hadn't announced it. We had just sort of put the site online quietly and started a little blog. And Adrian gave a presentation at Chippy, the Chicago Python users group. And apparently did very well. Adrian, man, he gives great demos. He's very good at making things look sexy. And we started getting, almost immediately, we started getting people asking us, okay, come on, release it already, release it already. So we did. We released it with a little bit of documentation and a tutorial, and it was nuts. Within a couple of hours, we had 100 people in Django's IRC chat room talking about it. We really did not expect to have this quick an influx and this quick an uptake. Frankly, Django wasn't even anywhere close to being what we would call done or even sort of feature complete or well designed. There was plenty of stuff in there at the time that we were really embarrassed by. But very quickly, and this is, it's crash course in open source, very quickly we started getting patches, and that started fixing this stuff a lot faster than we possibly could. The next day, Django supported WSGI. The day it was released, it only would run under mod Python. The day after it was released, it ran under WSGI. because of people's contributions from the community. And within, 5 days later, we had added SQLite 3 support. And this is just this is what I point to when people ask if releasing internal code is useful at all. And it sort of demonstratively is. You have people who are willing to knock off, you have those to-do lists, and down at the bottom you have the someday stuff, the things you want to do someday if you have the time. The great part is those things are higher up on other people's lists. So you get the stuff you always wished you had, but you don't actually have to do any of the work yourself. It's really nice. So in August, we had the first of we didn't realize at the time, but what eventually became a series of rather large, sweeping changes to Django's model syntax. Now remember, at the time, a model looked sort of like this. We had gone from data description to model. We had sort of identified the idea that we wanted that these things were models. We had sort of loosely adapted the model view controller terminology to make things easier for people to get started. But one of the things that really pissed a lot of people off was that you had this sort of repetitive way of declaring fields. They were in a list, and it just kind of looked ugly. You had to repeat the name twice. The first one is the name of the attribute, and the second one is the human readable name of the attribute. You can see from pub date and date published, et cetera. And a few people pointed us at Ian Bicking's SQL object, which supported a declarative style of defining your models. And so this was the change that we made, is to change that into the now familiar to anyone using Django or SQL object or a number of other declarative libraries in Python style. This has become something of a sort of hallmark of what we think of as Django-esque, is a more declarative way of programming. You're not necessarily dealing with calling functions imperative or defining data. You're sort of declaring there's this field slug and it's a slug field. There's this field question and it's a character field. Ruby folks would call this a DSL, a dynamic static language, domain-specific language, excuse me. Get that confused with something else. And whatever, if you want to call it that, fine. It's not exactly, there's nothing in this that's extending Python syntax in any way. It's using some built-in abilities of Python to do neat stuff like this. But it's definitely become something we try really hard to introduce as we bring along new features to sort of copy this declarative style of development. We think it matches more what you're doing as you write these parts of your program. And around then, we made the first of a series of rather ambitious and silly statements. Adrian wrote when he checked that change in. And again, we're still in 2005 here, August 2005. I can't think of any other backwards and compatible changes that we're planning before 1.0. If this isn't the last one, then it's at least the last major one. Well, he was wrong on all counts. Django 1.0 was released in September of this year, and this was by no means the last large change. And in fact, it was one of the smaller of the large changes that we've made in Django since then. The next one was a kind of cool move, and one that also sort of has started to define the way we think about Django-esque. The admin originally was always there. It was always loaded. You could, of course, just not ever load it in your browser, but you had to have the admin. It was a built-in part of Django's HTTP handling layer. And that's a bunch of memory overhead. That's a bunch of code that could potentially break. That's, if we were bad developers and there were insecurities, that would be an insecurity that everyone couldn't turn off. So we broke out the admin into a standalone app. This also marked the creation of Django Contrib, which is the location for stuff that ships with Django, but that isn't necessarily required. Some of it is sort of more important than others. But this marked the beginning of a trend of separating even farther the totally generic parts of Django that apply to everything, and then the sort of other stuff that we think most people need, an auth framework, an admin, et cetera. And we continued that trend. We have continued that trend of pulling more and more pieces out of the core. Originally, Django had a handful of models that were always installed. The auth app was built in. You couldn't define your own user table because we had ours. The admin was built in, et cetera. And over time, those have been pulled out into separate pieces. So now you can even use Django without a database, without any models, and people do. Late in the year was our first really large community contribution. Internationalization support. So the downside of being a bunch of developers from Kansas, we live 20 miles from the geographic center of the United States, and at that point, our code showed off our biases as Midwestern developers. People speak other languages? There are other character sets? So we had some contributions from a few people. Actually, this is where Malcolm Tredinnick first got started working on Django. He's now one of the, he's the most prolific committer to Django and has been for the past maybe 6 months or so. This is where he first got started fiddling around. And with that in place, we felt pretty comfortable releasing a version of Django. Until then, until this date, what are we looking here? November 16th. You had to download Django from the Subversion repository, and then people did. But there's an importance to a numbered and named release, and there's even more of an importance to a numbered and named 1.0 release. So why then did we call it 0.9? We had a big debate actually over the numbering. Some people said we should call it 0.5. We're halfway there. Some people said, just damn it, just call it 1.0. Really, what does it matter? To us, though, 1.0 meant something pretty specific, and it still does. 1.0 meant if you upgrade from 0.9 to 0. Something else, you kind of expect your code to break. That 0 there says it's not done. That 1, that kind of says it's done. Like, if you go from 1.0 to 1.1, you shouldn't expect all of your code to explode. If you go from 1.0 to 1.2, you might expect a few things to break because you skipped a version, but really, when you upgrade from 1.0 to 1.1, you should just get a few more features. We were really strongly influenced by the Python core team on this. Each successive Python version, starting from 2.0, 2.0, 2.1, 2.2, 2.3, 2.4, it's kind of a no-brainer of an upgrade. You just install the new version, you get some new stuff, and your code, modulo a few things, generally just keeps working. I've actually never ran into, since Python 2.0, I've never ran into a feature in a new version of Python that's made me have to change any of my code. And we wanted to be sort of that level of quality. So we called it 0.90. We had an install guide by that point. That was a pretty big step, actually. We released 0.91 pretty quickly afterwards, a few months later. It was basically 0.90 with a bunch of other stuff that had come. With the release, we had a bunch of new exposure, and with that exposure brings new users. So we had, and new developers, and so we had a bunch of new stuff in there, including the first new admin branch, not the second new admin branch. By this point, I think in Django 1.0, the admin is about the 6th incarnation of that particular feature. 5th. We stopped storing passwords in plain text. Yeah, good move, huh? We added the pretty error page, which I think is still kind of neat. We relaxed our pretty dogmatic stance against the use of includes and gave people an include tag, although you still shouldn't use it. We added OR lookups to the database API. Hey, that's a good feature. Wonder why anybody ever needed that. But then we sort of took a more holistic look at what was going on with Django at the time. And we realized there was still a lot of really confusing stuff going on. Remember, we're still dealing with this meta replacement for code generator thing. What happened when you defined a model in early Django was when the meta class ran, it actually, your class you defined became unaccessible. You couldn't import it anywhere. And instead, a module, not a model, but an actual Python module, magically appeared under Django.model. So you would define a class in myapp/polls/models.py, and you'd call it poll, and you'd try to import it and it wouldn't work. And you'd ask a question on the user's mailing list, and they would say, oh, you have to import Django.models.polls. I didn't define that. That file doesn't exist. If you go look in the Django models directory, it didn't exist. And this confused the crap out of people who knew what they were doing, who knew Python. And in fact, we got a question at one point on the user's mailing list from Guido, from the inventor of Python, about why he couldn't get something to work. And that might have been, I don't remember if that was actually the turning point, but it makes a better story if I say that was the moment when we realized we had to remove the magic. Sort of badly named effort in retrospect. Django is still relatively magical, but what we did was replace confusing and complicated and weird and outdated code with stuff that, while complex, ought to make sense to anyone who's reasonably proficient with Python. Python has one way of doing magical stuff, and it's a meta class. And it's a bit complicated, but once you understand meta classing, everything else kind of shakes out from there. As long as you're not doing really crazy weird stuff like dynamically generating modules, you're fine. This was a really big improvement. Before, like I said, you would have to import from this rather weird Django.models location. I think I'm missing, I think it was actually Django.models.polls.polls import poll, because saying it once wasn't enough. You had to say it 3 times for the incantation to work. Now you just import the model from where you defined it. Shocking. Another rather fun part is that because of this magical swizzling that went around, any imports that you defined in your data description were lost when it was turned into a module. So we had to inject stuff into the namespace for you to be able to use it. So you didn't have, the shakedown of this is you didn't have to import, say, date time. It was just magically there for you, which of course made syntax checkers and any sort of static analysis really, really awesome, because you'd be referring to stuff that just blatantly wasn't defined there. We moved around, in a sort of this continuing trend of taking things away from an imperative style and into a declarative style. We made the admin more declarative declaration. And we got rid of this nebulous, weird, magical module thing that existed there. Instead of importing this polls thing and calling this getList function, which you didn't write, and that doesn't exist on disk anywhere, and whose internals are incredibly hard to find anywhere, now you call a method on this objects thing, which is a manager, and you can go look up the implementation of filter and see exactly how it works, and it's very clear where it comes from. So we merged all that in 2006, and this change is highly backwards incompatible. Highly, highly. It made a lot of change. This is what Git tells me about it. 22,000 insertions, 15,000 deletions, 339 files changed. I think it's basically all of them is what this is telling you here. And once again, we got a little too big for our britches and said, hey, we're almost there. This is, once we fix a few bugs in this, and this inspired a couple of people, including Bill, to think, hey, after this merge, Django 1.0 can't be very far off. It was 2 years ago, keep in mind, 2.5. With that work and with some of the cleanup, a couple months later, we released 0.95. A formal packaging of all the significant advances, blah, blah, blah. This is the sexiest version of Django ever. And it was. Slicker, faster, easier, better. So this name, 0.95. We were going to call it 0.92, but we didn't think, we thought the change was big enough. We wanted to say that we were going to, we're getting there. We're getting towards 1. We decided early on we weren't going to do something silly like 0.100. So we only left ourselves a couple of revisions before we had to release a 1.0 by the law of numbers. Honestly, though, in retrospect, this should have been called Django 1.0. This was the first release of Django as you know it now. If you download 0.95 and start poking around, 85%, maybe 90% will work the way you expect it to. We made some bug fixes a couple of months later, Django 0.96, which was really nothing big. It was just sort of a cleanup from 0.95. In retrospect, we should have called this 1.1. It included a couple of cool new features now in Django. Django.newForms, the new forms library, which is no longer new. This is just Django.forms these days. And in a sort of embarrassing move, it actually wasn't until then that we had a test framework as part of Django. Yeah, that was one lesson that we didn't learn from Rails. From day one, Rails has had a built-in test harness, and the culture has encouraged people to write tests. Django didn't have a built-in test harness until, until March 2007. And as a result, our culture has suffered, and testing in the Django culture is not nearly as emphasized as it ought to be, and people don't do it as much as they should. That point, though, we had wised up on promising things. So when someone asked with 0.96, when will we release 1.0, Adrian smartly said, it'll be done when it's done. When it was done was about 18 months later. Change set 89,000. Now remember I said back towards the beginning, keep in mind the revision from which Django was moved from private to public. It was about revision 88,000, 8825. I actually think it's really significant that the 1.0 release of Django has roughly the same amount of change sets as the first public release. It really feels like that's a very succinct way of saying that Django 1.0 is as much community developed as it is developed by any of our core team. It really feels like over the past years, the needle has moved from the bulk of the code having been written by Adrian and Simon and me to a lesser extent to being written really by random contributors all over the world in the way that open source ought to work. And it was really neat to see that we sort of stumbled into this numerology as we released 1.0. So like I said, it took 18 months from 0.96 to 1.0. There were just over 3,000 commits. That doesn't count branch commits, so there were more there. And this is what I was saying earlier, 1,370 of them were direct from the community, patches taken as is and checked in. And probably another 50% of the ones left were started as a community contribution. We added 230 new people to our authors' acknowledgement file. We fixed over 2,000 bugs. We made a whole lot of code changes. We added 40,000 lines of new documentation. We had 4 new committers now that we didn't have when 0.96 was released. And we added a whole bunch of incredibly nifty new features in 1.0. Not just internationalization support, but full support for using Unicode internally. This just makes dealing with internationalization a breeze. One of the other contributors, Malcolm, assisted a while back with the internationalization of Pounce, the now departed social networking site built on Django. And he had said, when he did most of this Unicode work, he had said, hey, I think that it should be relatively simple to convert an app from pre-Unicode support to post-Unicode support. And when you do, alternate character sets will just work. Well, it turns out that that's actually what happened. Converting Pounce was incredibly simple and worked on a site that was running without causing any problems. So that was pretty neat to see. There was the query set refactor work, which finally rewrote the internals of how queries are constructed. You can now do a lot more with the ORM than you could previously. There was the second admin refactor called New Forms Admin. Django 1.0 ships with GeoDjango, which is, I think, the coolest part of Django by far. And I get to say that because I didn't write a single line of code in it, so I'm not patting myself on the back in any way here. If you haven't checked out GeoDjango, take a look. It extends Django's support for relational databases and adds support for geographic databases. And basically everything you'd expect to work does. You can do lookups based on boundary boxes and contains, and are these two polygons above or below each other, and it supports British chains and rods and inches and fathoms, you name it. Model forms a much better way of doing data validation and inserting them to a model. Django's template language now auto-escapes by default, protecting from sort of a whole class of cross-site security hacks. Actually, we have some stuff going into 1.1 to protect from cross-site request forgery attacks. So this sort of started the auto-escaping work, started the theme of Django should help people who even people don't quite understand how these things work. It should make the default be to not be susceptible to them. And Django 1.0 runs on Jython, thanks to Leslie here and Google for supporting the Summer of Code. This was a Summer of Code project. Helped shake out all the final bugs that prevent Django from running on actually really any other alternate VM. The most work was done by Leo Soto, who did the Jython integration, but we fixed the bugs that would have prevented Django from running on IronPython and PyPy and what have you. So Django now runs on at least 4 Python implementations that I know of. And we added a whole lot more. I'm just sort of giving the highlights. There's a big release document. The big change that was made in 1.0, and this comes with that 1.0 label. This is why I mentioned earlier what 1.0 means to us. The big change that came is API stability and forwards compatibility. Django 1.1, you will be able to upgrade to it and you will get new features and your 1.0 sites will not break. Now, we'll see how good we are at delivering on that promise, but that's the goal. We've documented pretty clearly what we mean when we say API stability. This isn't ABI interfaces. We're allowed to add new methods. We're allowed to change the meaning of old methods as long as we support the old usage in some backwards compatible way. And we have a schedule for deprecating features that we need to remove. There already are some stuff that we're going to start deprecating in future releases. We also have instituted a formal release process. Releases will happen roughly every 6 to 9 months, depending on the scope and the ambition of what we want to have in the next release. And we have a process for supporting previous releases. We've already released 1.01 and 1.02 as we've been developing Django 1.1. And we have a process for doing security releases and all of the stuff that you would expect from a functioning open source team. We feel sort of comfortable building this stuff on top of 1.0 because it's a stable platform. So in the last couple minutes, I'm going to talk really briefly about what's next for Django. This is the question that I get asked a lot. And I'm going to be deliberately myopic here and only look forward about 5 months to March when Django 1.1 is released. We have a roadmap for 1.1 which describes in some detail what will be in 1.1, what we're working on. I'll mention kind of the highlights. I'll also mention that this roadmap was sort of developed in a collaborative manner. We had a period when people submitted suggestions. We discussed those suggestions. We had a sort of rough voting period, not exactly voting, but more trying to ferret out consensus on various issues. And the features that we shook out for 1.1 are roughly the ones that most people want to see in the next version of Django. And we'll continue to do this going forward. So the idea is after each release to collect feedback on what should be in the next release, try to prioritize in as best we can, and move on from there. So the big stuff that should be in 1.1 is support for aggregation inside the ORM. This is started as another Summer of Code project, which is great. it'll look something like this. Sorry, I should mention, the work is being developed on a GitHub branch. Freakboy is one of the other core committers to Django, Russ. And that's where most of the work is happening on it, that and related branches. So this is what it'll vaguely look like. This is show me the average price of a book as well as the maximum price of a book. And you can see that you can either specify a name that you want to use for that thing or not. These average and max things are these aggregate objects. So yes, you can define your own types of aggregates for using built-in functions and anything other than that. Yeah, that should be average. Good call. That's a typo. The reason it's a typo is because in reality those are floating point numbers and they don't fit on a slide, so I truncated them the way that Python won't actually. You can aggregate across related fields. So here is show me the sum of all of the books that have an author. Here's some other stuff. You can also, besides just returning values, you can do what's called annotating, which is annotating a aggregate onto an existing query set. So here I'm looking up all the books, and I'm attaching to them a field telling me the max age of all the authors attached to that book. So this is vaguely what that will look like there. You can also do more complex stuff. This is show me all publishers who have more than one book ordered by the most number of books. You can see that when I annotate a query set, I can then use that field in the next queries. This work is nearing completion. It's sort of in the shake down all the bugs phase. This was close to done for 1.0. We just decided it was too big a change and too potentially destabilizing to check in sort of at the last minute. If this is something that you've been missing in Django, and a lot of people have, I'd really encourage you to check out the branch, try it out, see how it works, and please report bugs. We'd like to check it into trunk actually working and not have to fix bugs after the fact. So the more people we get sort of knocking the tires, the better. Along with this, we'll improve query set that update a little bit. A long-standing complaint is it's hard to do stuff like, update every person and increment their age. You have to write raw SQL to do that right now, which is sort of annoying. So we have a syntax which will look something sort of like this, which you have this filter, this field expression thing, which you can use to update. This would increment everybody's age. We're also working on support for model validation, which will work similar to the way you validate forms. Right now, if you stick invalid data in a model and save it, you'll get a direct database error. If you put a string into an integer field or you put a negative value into something with a constraint, you'll get an error all the way up from the database. We'll probably add something similar to this, validate equals true, and also a model.validate function, which will perform a similar thing to what forms do and check that the data saved on the model is actually valid. Work on this is taking place in a series of patches. So if you want to check it out, you can play around with it. My personal pet project is rolling this neat little third-party project into Django. Django Batch Admin lets you define actions and check boxes and perform bulk actions in the admin. It's relatively simple, ought to be built in, very useful. You can use this batch admin thing right now if you want it before 1.1, but I see no reason why it ought not to be the built-in. We're also going to introduce class-based generic views. This is also my sort of pet thing. This is another instance of replacing a more imperative style with a more declarative style. So instead of generic views being these kind of weird functions that you call and have a whole lot of arguments, they're just classes, and you subclass them and you define the fields you want to use on them, and it kind of just works. Again, there's quite a bit more, and we need help. We have large ambitions. We will not get all of them done. This is how open source gets done. So if I didn't mention something you want to see in Django, this is where to start. And I really appreciate both your time and, knock wood, your help. Thanks a lot.